Let's talk about the discriminant of a quadratic. Now, when you did the quadratic formula, you may have realized that sometimes you get different solutions. Sometimes you get two distinct real solutions. Sometimes you only get one solution. And sometimes your solutions are imaginary or complex. And all of this is because of the square root in here. The square root of a negative number, well, that's complex, that's imaginary. The square root of a positive number, that's just a number. And the square root of 0, well, that just gives you 0. So really, everything inside of the square root pretty much discriminates what kinds of roots we're going to have. And that's why we call the discriminant, big D, b squared minus 4ac. Now, just knowing what b squared minus 4ac is can tell us a lot about our roots, even without solving the quadratic formula. But let's do it anyway, just to visualize what's really going on. If we were to solve the quadratic formula for this case right here, where the discriminant is going to be positive, by the way, let's take a look here. We have negative b plus or minus the square root of b squared minus 4 times a times c. Well, 4 times 1 times negative 2, that's positive 8, all over 2a. So x is equal to negative 6 plus or minus the square root of 36 plus 8. Well, let's see. 36 plus 8, that gives us 44. We can take a 4 out of there, so that's going to be 2 root 11 all over 2, and this is equal to negative 3 plus or minus the square root of 11. Now, if you think of it this way, that the solutions of the quadratic formula are actually the roots or the x-intercepts of the parabola, what we can pretty much guess here is that this parabola crosses the x-axis twice, once at negative 3 plus root 11, and another time at negative 3 minus root 11. In other words, our parabola will look something like this, but not exactly, where it crosses the x-axis twice. Boom. This is what happens when my discriminant is positive. We get two distinct real roots. Let's take a look at another example. In this example, my discriminant is going to be equal to 0. Well, let's solve the quadratic formula anyway. So x is equal to negative b, that's 4 root 3, plus or minus the square root of b squared. 4 root 3 squared, well, 4 squared is 16, root 3 squared is 3, 16 times 3 is 48, minus 4 times 3 times 4, 4 times 3 is 12, times 4 is 48, all over 2a, 2 times 3 is 6. So x here is equal to, well, 48 minus 48, that cancels out. 4 root 3 plus 0, still 4 root 3. 4 root 3 minus 0, still 4 root 3. So this is 4 root 3 over 6, which reduces down to 2 root 3 over 3. Here we only have one particular solution, 2 root 3 over 3. And its graph will look something like this, where you'll notice that it touches the x-axis only once, and that is the vertex of the parabola. So this is what happens when my discriminant is equal to 0. And of course, there's one more case. What happens when the discriminant is negative? Well, let's take a look. X is equal to negative b plus or minus the square root of b squared minus 4ac, that's 40, all over 2a is 2. So x is equal to 6 plus or minus the square root of negative 4 is 2i, and this is all over 2, and this is equal to 3 plus or minus I. So when our discriminant is negative, we have two complex roots. Well, what does this mean in terms of my parabola? What it means is that it does not cross the x-axis. The entire parabola is either above or below the x-axis. And that is the discriminant. Thank you for watching.